Alright, now we are using a curved obstruction. And so over there is my little lights, 3 little lights in a triangle. And then I have a curved piece of fiberglass stake, tensioned like a bow with a rope to make it curved. I have my little camera height gauge there that's actually a 1/4 inch taller than the top case part of the camera as a reference. And then I have the camera. And the camera is filming right now, but it's too dark to see the display very well. I mean, it's too bright to see the display very well through the tank and all that. But you can see that looking down our curved, let's see, you can see it is curved, for sure it's curved. And we look down here and we see our 3 little lights, and you can see as the observer comes down, the refraction actually flattens out. See, look at that curved strip. We can see all the way from this end to all the way to the brick on the far end. And it makes it look almost a little concave. So the refraction's actually flattening out that curve visually. So you can see our camera would see all 3 of those little lights, even though those little lights should be below this horizon that we've created. Here's the little lights. There's a tinfoil boat floating in the brine gradient. I actually have a magnet taped into the bottom so I can drive it around with a big magnet. And just, let's see, yeah, so see, I can get right down to the very edge of that, and I can still see the lights beyond. The refraction is causing the chromatic aberration or chromatic dispersion. That's pretty cool. One other cool thing is I put this rusty old bolt in here as a spacer just to raise up the ramp here, and you can see it's been shedding off this rustiness, which has been flowing like smoke on a calm day all the way out most of the length of the tank, but it's staying at its density gradient level. Okay, now let's see if I can take this out of there and set it up on the ground to show that there's no line of sight without the gradient. Okay, so let's see. Unplug our lights. Just put our little lights right here. And take our curve out, and of course our curve will need to be put up on some bricks. So we grab our brick, and we put our brick in front of our light, set our curve up on the brick. Put our brick here, bolt in place, set this up on there. So now we've got the camera and we've still got our curve sitting up on the brick. Now we take the camera. Look at when I reach in, all the turbulence I'm making in the gradient. Okay, we take our camera out. Look at the salt water falling out of here. Anyway, we take our camera and we place it right here, just like it was. So now I've recreated the same setup outside the tank. I've got the brick and the light pack and the camera. And now, oh, one more thing. This guy. I had this like right about here or so. Now, as you can see, move the camera over a little. As soon as we get down to where the camera is, we get blocked off from those lights. We can see the top of that metal, but we can't actually see the lights. Let's see. I'm going to pause the camera and plug in the lights. Alright, I have now plugged in the lights, as you can see. But as I come down, even before I get to the top of the camera, the bottom two lights are cut off. I come down a little more, and I'm still not all the way behind the camera, and no lights are visible at all. Come down to where the camera is, and of course I can show that from the camera as well. I wonder, I can't really see what the camera is seeing, but I raise the camera up, assuming you can see the lights. I'm lowering it down, lowering it down, lowering it down, and there we go. So, it's definitely a curve, and it was definitely a high enough bulge in order to block off those lights if the light had not been bending.